So we are covering still the order Enterobacteriales, under which we have the genus, the family Enterobacteriaceae, Yersiniaceae, and Morganellaceae. Okay, so these are the important bacterial genera that we will cover. Okay. Okay, so this is simplified identification table. I've only selected the bare minimum for you to be able to split the genera. But you know very well, for the identification, I just put plus and minus, right? Plus and minus. But you know very well, no results is 100% plus, no results is 100% negative, right? So this is just for the majority. Mainly, this is what you expect. And we are talking about genera here, genus, which is very not a good argument, because different species within the same genus may give different biochemical results. Okay, now we will move on to the next genus, Salmonella. Okay, so this is discovered by Theobald Smith, and he named it after his partner, Daniel Salmon. Salmonella taxonomy was very, very messy in the past. Very, very messy. 4,000 over zeros. So which means when you get a Salmonella, you have to start doing serology tests. Can you imagine how do you target 4,000 species with just serology? It's just impossible. That's why they only target the ones that are important. Typhi, Typhimurium, Paratyphi. Okay? So they have recently revised the taxonomy. So now there are only 2 recognized species, Salmonella enterica, Salmonella bongori. Okay, and Salmonella enterica is divided into 6 subspecies. A lot of subspecies here, you need to know only the first one, because only subspecies enterica is for humans and warm-blooded animals. Okay. And most of the Salmonella that we'll be discussing later on are all within Salmonella enterica, subspecies enterica. So, for example, if it's Salmonella typhi in the past, it is actually now known as Salmonella enterica, subspecies enterica, Seroa typhi. A very long name. Okay, that's why you are allowed to write this way. Okay, but this is only for Salmonella. Remember that. So Salmonella bongori is actually subspecies 5. Okay, so Salmonella bongori is subspecies 5. Most of them are for species detected in reptiles. Okay, lizards, monitor lizards, chameleon, and all that. So this is how it's being divided. You have Salmonella bongori here, and subspecies 1 here. And under subspecies 1, we have typhoidal Salmonella and non-typhoidal Salmonella. What is important here is under typhoidal Salmonella, you have typhoid and paratyphoid. So the Salmonella that causes typhoid or paratyphoid fever are typhi, paratyphi. Okay? Then the rest are gastroenteritis. So this one is according to the White, Kaufman, and Lee Minor schemes for classification, serological classification of Salmonella. Okay? They have H antigens phase 1, phase 2. Why 2 phases? Because Salmonella has phase variation. Salmonella is a very clever pathogen. So when they feel threatened, they can actually choose another phase to present their flagella. So a different type of flagella to evade immune system. V1 is capsular. They use V1 only for salmonella. Okay, others we use K. Typhoid salmonellosis. Okay, so remember, only ones are typhi and paratyphi. Okay, these two are the ones that are important. Only human carriers, infective dose is hundreds to thousands. Okay, it's attachment to M cells, and then similar to the ones that we studied earlier, the EIEC, there is endocytosis invasion. So you can see from here, so it doesn't die when it's being when it's undergoing the endocytosis. In fact, it survives and then it can migrate to the lymph node. That's why it's termed, it enters the lymphatic tissue, and then sometimes it enters the bloodstream. So once it enters the bloodstream, it becomes general bacteremia or septicemia, blood infection. Okay? That's why you will have fever, persistent fever, long periods of unexplained fever. Okay, so when you have that, and you have also this abdominal roseola, which means you have flat red patches on your abdomen, then the doctor will consider taking your stool sample for salmonella identification. So you have antibiotics, but most of them remain 2 to 5% of the patients remain chronic stool uh, carriers. Although there are antibiotics, you have cases like where the bacteria hides within your organs. For example, Mary Malone, which is famously known as Typhoid Mary. Okay. So there are vaccines available. So whenever tourists want to come to Malaysia, the doctor may recommend that they do a vaccination against Salmonella typhi. Okay. So the other type of salmonellosis is enteric salmonellosis. So this is milder. So when you look at it, it is the infection source is whole eggs, meat products. Okay. So this one is oral infection, gastrointestinal tract. Okay. So this one is because the salmonella produces enterotoxin. So the enterotoxins cause the local inflammation with diarrhea and vomiting. Okay. So this is different from typhoid salmonellosis, where there is invasion. Okay, this one is mainly by enterotoxin production. Okay, so the mode is different. Okay, so most of these symptoms abate. Abate means self-limiting. You'll get well after a few days. So this is the main. These are the differences between typhoid and enteric salmonellosis. So you can see the infective dose is different. The incubation time is different. So prophylaxis is prevention, how you can prevent. So exposure prevention by carrying out good food hygiene, exposure prevention by drinking clean foods, drinking clean waters, and also vaccination possible. These are vaccination is usually for travelers, tourists. This is for isolation of salmonella in the stools. If it's enteritis, it is usually self-limiting. So it is when you have persistent fever, long term, no explanation, and maybe some redness in your abdomen. But you go to the doctor, you tell them you have this problem, and the doctor might take a stool sample from you. That's why salmonella, those with suspected salmonella typhoid or typhi, The stools are normal, not watery or anything, just normal stools. Okay? But because of that, the number of salmonella in the stool sample is low. When it's low, you need to enrich. So we use the term enrichment. Enrichment means we want to make sure that the bacteria that we want grow, so that it's easier for us to carry on the next step. So pre-enrichment is for dried foods. Why do you need pre-enrichment for dried foods? Because when you process like dried milk, you have to prepare milk powder. It's a very stressful environment for the bacteria. There's no water, okay, so it's very dry. The bacteria is already at near sublethal injury, which means if you further injure it, it will die. But that is not what you want. You want to detect the bacteria in your sample. That's why you have to carry out a gentle pre-enrichment step. A gentle pre-enrichment step means you use lactose broth. After that, only then you start carrying out your selective enrichment. Recommended enrichment broths are now the tetrathionate broth and the Rappaport vestigialis broth. And so this is the standard. For Rappaport vestigialis, you will incubate at 42 degrees Celsius, 35 or 37. Because in most labs, we have at 37, so it's 37. In the past, we used selenite cysteine also. We also use selenite cysteine broth, but it is more toxic. So now we are in the process of replacing selenite cysteine with Rappaport vestigialis. Okay, so this is the more uh, common combination that you will see in the labs. So only after you enrich using this broth, you will carry out selective plating on all these types of media. So the normal ones, brilliant green, bismuth sulfate, Salmonella, Shigella, agar, this oxyfolate citrate, hectone, enteric agar, and XLB. Okay? There are different types of selective and differential media. So if it's clinical samples after you obtain presumptive salmonella, you have to do serology, okay, serotyping. For food samples, you have to carry out biochemical testing to carry the identification step. Okay, we'll do the dilution streaking, and from there we can see the color. So this is McConkey, and this is pectone enteric agar. So you can see these are lactose fermenters, so it's red, but they are not lactose fermenters, salmonella, so it's colorless. For hectone enteric agar, you can see salmonella produces H2S, so it's blackish. So Shigella is named after Kiyoshi Shiga, Japanese microbiologist. So 100 years ago, 4 species, Shigella flexneri, boides, soni, and dysentery, all cause dysentery. Okay? So what is important here is the reservoir are only primates and men. Okay? The infective dose is very small. So when you ingest this bacteria can withstand the stomach acid, then it grows in the small intestines, but attacks the large intestine. So you can see that it doesn't die when it's endocytosized, but in fact it can evade and then spread through the epithelial lining. The different from Salmonella typhi, it doesn't enter the bloodstream. Okay, so it doesn't cause bacteremia. Okay, because Shigella that enters the bloodstream is quickly killed. Okay, so it causes damage in the peripheral cells, in the neighboring cells. It just spreads. Okay, but it doesn't go to the lymphatic system. It doesn't go to the bloodstream. It is able to carry this out because it has toxins, Shiga toxin, and that inhibits protein synthesis. Okay? So because it destroys the epithelial cell, you will have bloody feces with mucus, pus, and blood. So it is also a non-lactose fermenter. So usually procedures in the media are similar to Salmonella, but the main differentiating factor is Salmonella tends to produce H2S, whereas Shigella don't. Shigella is also non-motile, whereas Salmonella is. Okay, so these are Shigella. You can see on the HEA, it doesn't produce H2S, so it's not as dark as the Salmonella. So for Klebsiella or Klebsiella pneumonia, you can see that it has capsules. Okay, you can see very clearly from when you're growing Klebsiella on plates, it's very mucoid. Okay, it's very mucoid, very wet, very typical of Klebsiella. Then when you look under the capsule staining, you'll see a clearing around the cell. So for Proteus, you'll see swarming here. Okay, this shows the swarming concentric rings of the Proteus as it swims outside the plate. So Enterobacter becoming more and more important because they are causing a lot more multiple resistant infections in hospitals. Yersinia is now under Yersiniaceae. Same goes for Morganella and Proteus. Morganella and Proteus is now under Morganellaceae, a different family. So now let's look at Yersiniaceae. Under Yersiniaceae, we'll look at Yersinia. The type species is Yersinia pestis. The causative pathogen for plague, Black Death, or bubonic plague. Okay, so this is the one that decimated more than nearly half of Europe's population at that time. So the initial symptom is the bubo, the swelling of your lymph nodes. Okay, that is the first stage. The second stage is when the bacteria enters the bloodstream and it spreads to other organs. So it has a characteristic bipolar staining. Bipolar staining means if you look under the microscope, you'll see only the ends of the cell are stained, not the middle. Yersinia pestis, you have several cycles. You have the sylvatic cycle where the bacteria is just being transmitted among the rodents in the wild. Okay? But then sometimes it's passed on to the rats, and then if the rats go to the cities or towns, that's where you have the urban cycle. Okay? Bubonic plague means the bacteria is still constrained to the lymph nodes. So it's still, the infection rate is still not high. The problem starts when you have this stage, bacteremic seeding of the lungs. When the bacteria enters the lungs and then the person starts coughing, that's when you have your pneumonic plague. That's where the infection rate spikes, which means breathing, coughing, then inhalation of the aerosols. That's why it is dangerous. So you have the sylvatic cycle here, and then the pneumonic plague here. So man-to-man transmission. Okay, so that's why any contact persons must be quarantined because they do not want to have that stage, the airborne transmission, and they must make sure that the person is not infected before they release them. Of course, for Yersinia pestis, you need antibiotics. So other than Yersinia pestis that causes bubonic plague, you also have enteritis Yersinia that causes gastrointestinal diseases. But okay, so this is when you ingest the bacteria and it causes abdominal pains. So this is more important in Europe, okay, temperate countries.